politically correct.
Yes, I loved it.
Mm-hmm.
Yes.
Well, Rudolph, we're here just chilling at the North Pole, putting the finishing touches on all the kids' Christmas gifts.
Yep. And we realized that some of you may not know the names or formulas of ionic compounds.
Yep, it's true. So we are going to start with going over those names with you. Kind of like you are Rudolph, and I am Santa.
Oh, those are our names.
Yeah.
Gotcha.
See, that was my
Okay,
connection right
yeah.
there. Okay, so, of course, I'm going to use said pointer and said... And here it is.
Oh, Santa, you and technology.
I know. Alright, so, what is a name? What is a name? I think that's a Shakespeare thing.
Yeah.
Okay, so a name is called... Yeah. Okay, so, ionic compounds. Ionics are when we take a metal and a non-metal and we put them together.
Okay.
They form a bond.
An ionic bond.
An ionic bond.
Ooh,
Yeah, see what I did there? Okay, so first thing we're going to talk about is monatomic ions. Mono meaning one. Okay, so these are single atoms or single ions, if you will.
Okay.
So when we're talking about a cation or an anion, okay?
A positive or a negative.
Absolutely.
Single atom. Okay.
Okay. So a little review, because you guys already know about cations and anions.
Yes.
Okay, cations, they are the atom with the plus sign.
Ooh, the positive ones. Okay.
Exactly. So like sodium. Okay. Cations tend to lose electrons.
Ooh, okay.
Because they are positive.
Positive. And those would be the metals.
Right, exactly.
Okay, good.
Okay, and anions tend to gain electrons because they are the non-metals.
Ah, they're negative. Okay.
So when you start to name things, okay, the cation always keeps its name.
Oh, that's easy.
Yeah, so sodium, you're sodium. You don't, no name change for you. You're like the boy in a relationship.
Oh, okay. Potassium. Gotcha.
Yes. Anions, however, you drop the ending and add IDE.
Oh, it makes it sound sciencey.
It does. So instead of you're not sodium chlorine, you're sodium chloride.
Oh, love it. Not oxygen, but oxide.
Exactly.
Ooh,
okay.
Fun.
So just a little review when we go back, when we bond. Okay, so groups 1, 2, and 13 are going to be our cations, and then groups 15, 16, and 17 are anions.
Okay.
And we talked a little bit about group 14 and being able to play for both teams. So now, of course, this is where they get to be a cation or an anion.
And we're going to talk about how to tell the difference?
Absolutely.
Excellent.
Okay.
Excellent.
So let's just dive into it after we talk real quickly about these transitions.
Oh, love the transition metals.
Those tricky transitions, see?
That alliteration.
So, some of these guys, as what we said, they're tricky, have more than one ion form.
Ooh, whoa.
I know. Pain in the bottom dollar.
Yeah.
So, here's what we got. We got, for example, copper 1 and copper 2. Okay?
Okay, so copper 1 is 1 because of its charge?
Absolutely.
Okay, so copper 1 has a 1 charge, copper 2 has a 2 charge. That's why it says 2 plus.
Exactly.
Oh, okay.
Okay, so in this case, copper 1 only lost 1 electron.
Okay.
And copper 2 lost 2 electrons.
Gotcha. They're both cations.
Exactly.
Okay.
Okay, now this only happens with the metals in the transition area.
So only 3 through 12.
Only 3 through 12, yes.
Gotcha.
Okay? Now, there's another one we call polyatomic ions.
Oh, that's
Poly meaning?
Well, mono meant 1, poly is more than 1?
Yeah, many, if you
Many?
will.
Okay.
So there's some that are put together, but they act as like one atom by themselves. Okay? So sulfate, I'm sure you've heard of it. We used to fill it. It's actually sulfur and oxygen put together, but it gets an overall charge just for them together.
Okay, so sulfur and oxygen together, it acts as one thing.
Exactly.
So it's always SO4. Okay, so it's one thing.
Yes.
Gotcha.
Because you would never say like sodium, sulfur, oxygen. That just sounds silly.
Ridiculous.
So that's why it gets its own name of sulfate. So it'd be like sodium sulfate.
That
sounds a lot more sciencey, right?
Yeah.
Okay, so they're all assigned their own charges. Now, you're going to get a chart of these. The kids will get a chart, not you, not Rudolph. You know them.
No, high expectations of
yes.
North Pole.
Exactly. So you'll already get, all you have to do is look these up, and the name's right there.
Boom.
And the charge. So not too much. All you have to do is look at a chart for these. You can handle that.
Yeah.
Okay. So when you get to naming, we have binary compounds.
Ooh.
Bi meaning
2.
2. Okay. So these are compounds composed of 2 elements.
That makes sense.
Yeah. So of course it's always composed of a cation and an anion.
Gotcha. Because it's ionic.
Ionic is cation and anion.
Gotcha.
Yes.
Okay.
And it's also metal, non-metal.
Metal, non-metal.
Okay.
Okay.
So when you go to write the name, NaCl, if you will, think easy salt. Okay. The cation is written first.
So Na is the positive charge.
So it's written first. And then chlorine is the anion, so it's written second.
Okay.
Okay? That's not the example that I thought we had coming up. Clearly.
No, but very close.
Very close. So, potassium, since it's the metal, it's written first. Chlorine, anion, is written second.
Love it.
Okay, so we would call K the potassium, obviously.
K is potassium, okay.
Mm-hmm.
Look that up.
That's like the boy doesn't get a name change.
No name change.
And then chlorine turns into chloride.
Okay, so potassium, chlorine turns into chloride, so it's potassium chloride.
Absolutely.
Okay. Now, and that's the same thing every time? The second one I always drop the ending?
The second one you always drop the ending, yes.
First one was keep it as it is?
How it is, yep.
Seems pretty straightforward.
Mm-hmm. Okay. So this is just talking about when the subscripts are involved. We're just not going to focus too much on it. However, just focusing on, again, that the cation is always written first. So sodium chloride.
Hey, there it is.
There it is. Lithium oxide. Now,
Gotcha.
you might be thrown because that Li has a 2 after.
Yeah.
You're like, where did that come from? Well, that's when we start talking about the charges.
All right. So, okay, so we're not going to worry about that right now?
We'll talk about it right now.
We'll talk about it right now?
Okay, so lithium, when it gives up one electron, becomes a positive 1.
Yes.
Okay, so positive 1 usually wants to find a friend with a positive 1.
And I know that because it is in the first column.
Right. Okay, so we want to make them happy. They will both want to have 8. Well, however, when it binds with oxygen here, that oxygen has a negative 2 charge.
Okay.
So in order for that to have an overall charge of neutral or 0, if you will, you need to have 2 lithiums, because they have 2 plus 1s.
Okay.
Plus an oxygen, 2 minuses, and then bond it.
Okay. Oh, I get you. So lithium's plus 1.
Mm-hmm.
But if I have 2 of those, it's plus 2.
Yep.
Oxygen is minus 2. Plus 2 minus 2
Equals 0.
0.
Mm-hmm. Okay.
Okay.
So we try to name them as simple as possible. Magnesium chloride. Okay. Potassium iodide.
So that little number doesn't affect the name at all?
No, the little number doesn't affect the name at all.
Okay.
Okay. And then some last things that you might want to. This is where the tricky part comes in.
A lot.
These are when we talk about those tricky transitions.
Those tricky
Okay.
transitions.
This is the only time that that number means something.
Okay.
Okay. So when you're naming, for example, if it has a transition and it has a different charge, could be a plus 2, could be a plus 3. When you write the name, you put the in Roman numerals, in parentheses, you write what the charge is.
Okay, so when I have a transition metal, let me see if I get this right. When I have transition metal, the charge can be different, so I have to tell you what the charge is.
Absolutely.
Okay, and I do that by putting it in parentheses.
In between the cation and anion. Yes.
Okay, I got you.
Okay. And then of course we always want the compound to equal 0. So that's why we talked about the charges.
Got you. So, okay, so in CuNO3 like that example. Okay, so the copper nitrate. But I need my Roman numerals because I need to tell you what copper is.
Right.
Okay.
So that's why the name is copper 2 nitrate, because if it was copper 1 nitrate, it wouldn't fit together correctly.
Gotcha.
Okay.
Okay.
Okay, so you'll get a common list. Here's a few that you'll probably use regularly.
Okay.
Okay, ammonium, which is a positive polyatomic, which is very rare.
I was gonna say.
Most of the time they're anions.
Okay.
And then phosphate, which I'm sure you heard of, which is a common anion.
Yeah, very. All over the place.
So here's a little couple practices ones.
I
Okay.
like this one.
So you're gonna take the ions in the group, if you will, in the column.
Ooh.
See it in
Columns
there?
go up and down. Life skill.
And in the box, you're gonna combine them.
Okay.
Okay. So you would just write NH4Cl.
Okay, makes sense because plus 1, negative 1, 0.
Absolutely.
Have to equal 0. The charges have to equal 0.
Right.
Got
So and ammonium chloride is the name.
Oh man.
Okay. Very easy. Okay. So if we go underneath that, we have now aluminum and chlorine.
Ooh. Okay.
Now aluminum's got a plus 3. So now I have plus 3 in the cation and a minus 1 in the negative.
Okay.
So how's that going to work
So
out?
if I have a plus 3, I'm going to need a negative 3, right?
Correct.
So I'm going to need 3 negative 1s.
Absolutely.
So I would need 3 chlorides and 1 aluminum.
Yes.
So it'd be AlCl3.
Yes. Exactly.
Okay.
So I'd write it AlCl3 for aluminum chloride.
Okay, because my charges have to balance out.
Now iron falls in that tricky transition column.
Oh man.
Okay. So, but see, as you can tell here, they've denoted for us what iron we're working with.
So iron 2. So I know it has a 2 charge.
Yep.
So that means I have to have 2 chlorines, right?
Right.
Because if I have a positive 2, I need to have a total of negative 2.
Yes.
So it'd be FeCl2.
Yes, absolutely.
Okay, because my charges have to balance out.
Yes. And what I want to do is I'm just going to let you guys take a run for it. You have 6 more.
Okay.
Okay?
Mhm.
You guys can practice. I got to go feed this reindeer. He's looking really
Man.
hungry. But you're going to need to put
Wow.
ammonium with sulfide, aluminum with sulfide, iron with sulfide. And then we'll check your answers in class to make sure you know what you're doing.
Fantastic. Love it.
Okay? So while we got to get back to the sleigh, see ya.